Okay, Honors 2, here we go with the first of a couple videos for Day 5, Lesson 5. This is half-angle identities. Okay, so I don't really know what I was thinking in the last video saying that we weren't going to do these. Sorry about that. So we'll do the proofs of them, which are not going to be bad because we'll use double angle. And we'll look at some equations that are just a little bit more involved than what you've seen before. Okay, so here we go. Here we've got 4 equations, and there's no restriction on theta, so we're going to find general solutions for all of these, right? A, B, C, and D. And we're going to use some of the identities that we've learned in the past in order to solve these. Okay, first one. Got sine squared theta, sine theta, and cosine squared. So I believe I mentioned this in a video before, but we like equations where we have all the same argument. So in this case, we have theta, theta, and theta, so that's good. But we also ideally want the same trig function. Okay, so here I have sine, all the squared sine theta, I have sine theta. That means I want to convert this to sine to make my equation a little bit easier. So we'll use a Pythagorean and say that this is 1 minus sine squared theta. Okay. If we move that over, we'll have 2 sine squared. If we move this over, we'll have minus 1. So this whole equation becomes 2 sine squared theta minus sine theta minus 1 is 0. Okay? And now this is a quadratic, a hidden quadratic form. So if we let u be sine theta, we get 2u squared minus u minus 1 is 0. And hopefully that factors. I think it's going to. Yeah. So we get 2u plus 1, u minus 1 is 0. That means here that if I resubstitute for u and solve, that means sine theta is negative a half, or sine theta is 1. This is good because both of these numbers appear in the unit circle, so we don't need a calculator to solve. So in this case, let's see, if the sine is negative a half, I'll draw that over here. Well, we can be in quadrant 3 or quadrant 4. We're not told degrees or radians. I'm going to use degrees for this. So this is 210, and this is 330. Okay, so in this case, theta could be 210 degrees plus or minus 360 degrees, okay? Or it could be 330 degrees plus or minus 360 degrees, okay? All right, so that's our general solution. Here are 2 angles where the sine is equal to negative a half, and we're adding or subtracting a multiple of the period to get all the answers. In the other part, sine theta is 1. Well, that's just going to be theta is equal to 90 degrees plus or minus 360k. Wow. Okay, so we have 1, 2, 3 different equations that produce an infinite amount of angles that work for this. Next one. Well, same as before, we have the same argument. We have theta and theta, but I've got sine and cosine. It's not so easy to manipulate these to get the other. So what I'm going to do in this case is divide by cosine. Divide both sides by cosine. So that gives 2 tan theta equals 1. Now, because we divided by cosine, right, to get this form, we know that it's big trouble if cosine is equal to 0. So I'm going to do this one in radians. I'm going to put that theta cannot be anywhere where cosine is 0. So that would be pi over 2 plus or minus pi k. Okay? So if I get any of those answers, I'm going to throw them out, right? This is one angle where the cosine is 0. Right, that's straight up on the unit circle. If I add pi, it goes straight down. Okay, so this is nice in the sense that we only have to write one answer. If I go back to the original equation and solve it, I've got tan theta equals 1/2. And so that I actually don't think is solvable without a calculator. So give me a second. I'm gonna get a calculator, find out what the answer to this is. And I'm in degree mode, so let me change this to radians. And now we can solve. And so remember, guys, the way, if we have use of a calculator, the way that we solve something like this, to isolate theta here, we're going to take the arctan or the tan -1 of both sides. So this is going to be what we put in the calculator, tan inverse of 1/2. If we do that, we get 0.463. And I'm just checking that I'm not being an idiot and that's not a whole number. Radians. Let's check. No, it's not. Okay, so if we're in radians, one answer here is theta could be 0.464, 0.464 radians. And because it's tangent and the period of tangent is pi, I'm going to add or subtract pi k to that. All right. So 0.464, this is roughly in radians, this is 3.14. This is 1.57, so 0.464 is somewhere in quadrant 1, which makes sense. And then if we add pi, we're going to go down to quadrant 3, where both sine and cosine are negative, so that makes sense. So that's going to be our answer in degrees. Okay, 2 more. You have a hint for C, right? It says substitute using Pythagorean identities and square both sides, check for extraneous solutions. So the reason in this one that we can't do what we did in here is because if I divide by cosine, I have to divide that by cosine, but I also have to divide that by cosine, so it's a little bit messier. All right. So I'm going to do everything in terms of sine, which means I need to convert that. So this left side stuff is equal to, now this is going to be the square root of 1 minus sine squared theta plus 1. Okay. Kind of messy. If we square both sides, we're going to get 4 sine squared theta is equal to 1 minus sine squared theta. So that would be this term squared. When I square this whole thing, I'm going to have 2 times this product. So that's plus 2 square root 1 minus sine squared theta plus 1. Wow. Okay. Let me just double check that's right. So this squared is that. Yeah. This times this doubled is that. Yeah. This squared is that. All right. Geez. So does this clean up at all? Yeah, I think a little bit. These cancel. And when I take this and move it over here, it becomes 5 sine squared, right? So really we've got 5 sine squared theta is equal to 2 root 1 minus sine squared theta. If we square both of those, we get 25 sine to the 4th theta is equal to 4 times, well, you know what, let's just distribute it. 4 minus 4 sine squared theta. Let's double check that right. So that squared is 4. This is 1 minus sine squared. The 4 distributes, yeah. Okay, then we get, if we combine all this, 25 sine of the fourth theta plus 4 sine squared theta minus 4 is 0. So that's 25u squared plus 4u minus 4 is equal to 0 if u is sine squared theta. Now, is that going to factor 104? 104. 104, 25, and 4, no. 20 and 5, no. I don't think this will factor, guys. So let's use quad form. U is equal to negative 4 plus or minus the square root of 16 minus 4 times 25 times negative 4 all over 2a, so that's 100, which is negative 4. Wow, this problem is brutal. Plus or minus the square root of 16 plus 16 times 25 all over 100. That's equal to negative 4 plus or minus 4. So I'm going to take the root 16 out. And if we take that out, that's 1 plus it's 26 over 100. Which is the same thing as negative 1 plus or minus root 26 over 25. And if u is equal to sine squared, then negative 1 minus, that's not going to be possible. You can't have a negative result after you square this. Okay, so we're only going to take the top, or the positive part. So this is negative 1 plus root 26 over 25. So that means that sine squared theta is equal to that. Goodness. So that means that theta is equal to sine theta is equal to the square root of negative 1 plus root 26 over 25, plus or minus. So theta is equal to the sine inverse of plus or minus square root negative 1 plus root 26 over 25. Okay, I'm going to stop there, this video, guys, because, to be honest, I'm a little bit worried that something's wrong here. And I'll pick up the next video with a solution to this, and then we'll keep going. Okay? So, see you.